Good day everyone. Today I'm going to discuss to you about Introduction to R3, Distance and Midpoint Formulas, Planes and Spheres in R3. Now let's recall some concepts that are important for these topics. First is R3. It is a way of relating points in space with ordered triples denoted by x, y, and z. If you remember in R2, any points can be denoted by x, y. The same applies for R3. Second, there are three coordinate axes, namely x, y, and z. As you can see in this 3D coordinate system, here are the three coordinate axes, and if you take any point in space, we can denote it by x, y, and z. In this example, the point 336 means that the distance of x, y, and z from the origin is 3, 3, and 6 respectively. Also, there are three planes, namely xy, yz, and xz planes. To visualize these planes, here is an image. There are also 8 octants, just like in R2 where there are 4 quadrants. The first octant is the octant where all coordinates are positive, meaning x, y, and z are all positive numbers. In our previous example, 336 are all positive numbers, therefore the point is in the first octant. Next, we recall the distance formula. Given 2 points, P1 of x1, y1, z1, and P2 of x2, y2, z2, the distance between them is given by the distance of P1 and P2 is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. Next, we recall the midpoint formula. Given 2 points P1 of x1, y1, z1 and P2 of x2, y2, z2, the midpoint M is given by M of x1 plus x2 all over 2, y1 plus y2 all over 2, and z1 plus z2 all over 2. The distance formula and midpoint formula of R3 is very similar to R2, with just an additional coordinate. In R3, a plane is a flat surface defined by the equation ax plus by plus cz plus d equals 0, where a, b, c, and d are all real numbers and at least one of a, b, c is non-zero. If you recall the three planes x, y, yz, and xz, their equations are defined by this definition. Next is the definition of a sphere. In R3, a sphere is a collection of points equidistant from one central point called the center, with the distance from the center being the radius. If you remember, in R2, this is the definition of a circle. The center radius form of the equation of a sphere is given by x minus h squared plus y minus k squared plus z minus l squared equals r squared. The equation of a sphere is very similar to the equation of a circle with just an additional coordinate. Here, the center is located at HKL and with radius of length r. Now let's try to solve some problems. Here in problem 1, given that the midpoint of line AB is at 3, 6, negative 2, and that B is at point 3 over 7, pi minus e, and 4, where is A located? I recommend pausing the video and try to solve the problem by yourself and check if your answer is correct. Now, I will show you the solution. As you can see, we can apply the midpoint formula here. We are given the coordinates of the midpoint as well as the coordinates of point B, which we will consider as P of x1, y1, z1 arbitrarily. Denoting the midpoint coordinates as M of x, m, y, m, z, m, we can solve for x2. For example, we can take the x coordinate of the midpoint formula, x1 plus x2 all over 2, and we equate it to xm. But since the x2 is the missing variable, we must isolate it using algebra by multiplying both sides by 2 and subtracting both sides by x1. Thus, the resulting equation is x2 is equal to 2xm minus x1. This extends to all coordinates, and thus by substituting the given values, we can get x2, y2, and z2, or the coordinates of point A. Thus, the coordinates of point A are p of 39 over 7, 12 minus pi plus e, and negative 8. So, this is the solution for problem 1. Here in our next problem, we must solve for the radius and center of the sphere given by the equation x squared plus y squared plus z squared minus 6x plus 10y plus 26 equals 0. Again, just like in the previous problem, I recommend pausing the video and try to solve the problem by yourself and check if your answer is correct. Now, I will show you the solution. First, we recall that the center radius form of the equation of a sphere is x minus h squared plus y minus k squared plus z minus l squared is equal to r squared. Thus, we must complete the square for x, y, and z to attain this form. So how can we do this? For x, we have x squared minus 6x, and to complete this, we must add 6 over 2 squared or 9 to both sides. But where did 6 over 2 squared come from? This is a common method used for completing the square. The formula used to find the number that we must add both sides is b over 2a squared. Now we substitute b to be 6 and a to be 1. So it becomes 6 over 2 raised to 2, which is equal to 9. Then we isolate x squared minus 6x plus 9 to be factored later. The same method was used for completing y squared plus 10y. Here, we added 10 over 2 squared or 25 to both sides to complete the square. For z squared is already complete because there is no coefficient with variable z to be seen. It means that the coefficient of z is 0. So we have x squared minus 6x plus 9 plus y squared plus 10y plus 25 plus z squared plus 26 is equal to 34. Then we subtract 26 both sides, then we factor x squared minus 6x plus 9 and y squared plus 10y plus 25 since they are now both perfect squares, resulting in x minus 3 squared plus y plus 5 squared plus z squared is equal to 8. From the center radius form, we can deduce that the center of the sphere is at 3, negative 5, and 0, while the radius is the square root of 8 or 2 square root of 2. I hope you understood the topics discussed. If you have any questions, don't hesitate to ask your instructor for help, and good luck on your exam. I hope to see you again. Thank you so much for listening.